this on this computer. So a homologous series is a family with similar compounds, okay, with similar chemical properties, due to the same functional group, like your alcohol that we mentioned here. Ethane is an alkene, which means it's, what's the formula? CnH2n, unsaturated, clear. That's what we said, it can easily react. So draw the structure. So how many carbons does ethane have? What does the word ethylene mean? It means 2 carbons. You should know by that, huh? 2 carbons, clear. Ethylene, 2 carbons. Methyl, 1 carbon. Propyl, 2 carbons, 3 carbons. Butyl, 4 carbons. So ethane, it simply means C2H4. But remember, because it's unsaturated, it is 1 pair of a double what? Double bond. Yeah, done. Clear. Describe how aqueous bromine is used to show that ethane is an unsaturated compound. So how do you show that? Experiment 2 marks. How do you show that? Do you know how do you show that? So we can use the bromine in order to distinguish between alkenes and alkanes. Eh? So how do you do that, Brandon? How do you do that?
Wouldn't you put the alkene in bromine water, and if it would decolorize, it would mean that there would be presence of an alkane.
Yeah.
But if it doesn't decolorize, then it means that it's an alkene.
Yeah, but the question,
unsaturated.
yes, the question is simply saying, so yes, you have answered, but the other alkane part is not necessary because you simply want to prove that it's unsaturated. So if it decolorize bromine water, it means it's an unsaturated compound. Now, my question is this, what state is this? Because there's something that, of course, they won't penalize you. You get the 2 marks, but what's the correct way to actually describe how we do that? Is this a gas or a liquid? At room temperature, what do you know? Brandon, is this a gas, a liquid, or a solid at room temperature? So you need to know that whether alkenes or alkanes, if you go and read your chemistry completely, both of them, from C1 to C4, I think you have that in your chemistry complete. They are all gases at room temperature altogether. So you bubble through, the reason why I'm saying both say gas, you bubble through that in bromine water altogether. You bubble this gas in bromine water. When you bubble that in bromine water, it decolorises bromine water. Clear?
Yes, sir.
No need for explanation because the question simply says describe how you do that. Clear? Okay, now, and it decolorises bromine water. Now, ethane is manufactured by cracking. State the conditions needed for cracking. State the 2 conditions needed for cracking. So, by the way, there are 2 types of cracking. There is thermal cracking, of which you do more that in A level, and there is catalytic cracking. Catalytic cracking here, making use of an enzyme. So one of the conditions, if you're using catalytic, you have to use an enzyme. Sorry, not an enzyme. Sorry, you have to use a catalyst. Sorry about that. Not enzymes. You have to use a catalyst, a transition metal. Or you can use very high temperatures. Clear? Thermal, very high temperatures and pressure to crack. Now complete the chemical reaction between the cracking of what? So they've given you one of the compounds. Can you see this? They've given you one of the compounds. Oh, one eye, we lost you. We have been given one of them. So how do you complete? It's easier. Because when we crack, whatever we get on the products, should be exactly equal in terms of the number of carbons with the reactants altogether. That's how easy if you want to remember that. How many carbons do I have here? 16. And how many carbons do I have here? 3, yeah? So what I need to form is see what? Subtract 3 from 16, what do you get? C13, huh? Can you see that? H, how many do I have? 34, subtract 6, what are you left with? 34 minus 6, 20 what?
28.
8.
That's how easy that is. But they should balance. Now, the naming is not important, which is not in your syllabus anyway. You only know how to name up to C10. And now, alkenes, and alcohols are 3 different homologous series of organic compounds. State what is meant by the term homologous series. Homologous series, what does that mean? Homologous series. What was the 1 mark? I think it's 1 mark. So how do you define it? Let me see if it's 1 mark. I think it's 1 mark. I have to push 2 marks. Oh, okay. Homologous series. What's the definition of a homologous series?
Would you say similar compounds with similar chemical properties?
Maybe. Someone wants to try to define homologous series?
Is it a group of organic compounds of the same functional group and similar chemical properties?
Maybe, that's correct. So it's a group or a sequence of compounds, a group of organic compounds with same functional group and similar chemical properties. Clear? So the definition is a group or a sequence of compounds with the same functional group and chemical properties. That's a homologous series. Now the structures of some alkanes, alkenes, and alcohols are shown. Which two of these compounds, F, G, H, I, J, and K, are saturated, you see, hydrocarbons? And explain your answer. Saturated hydrocarbons. So which one? We want to list 2, huh? They want 2. Is this one saturated here?
No.
Saturated, huh?
But would it be H and
You are now confusing. What did I say about saturated? Saturated, very stable and cannot easily react. Huh? So what are saturated? You made the same mistake. This is unsaturated here. Unsaturated can easily react. This is unsaturated here. Saturated, yes. Saturated, yes. Clear then. Saturated. Because it cannot easily react. That's why if you want to react with halogens, you have to use UV light. Otherwise, without UV light, no reaction. Clear now? So F and G. Are we together? Because they belong to because they belong to CH2N plus 2. Huh? Are we together there? Make sense?
Yes, sir.
One of these compounds is the main constituent of natural gas, which is easy. They love that. Which one? Your natural gas is what? Me. If you are reading chemistry, methane is natural gas. And what is methane? Natural gas. CH4. Which two of these compounds are alkenes? You now know the answer now. Which of these two are alkenes?
J and H.
J and H. Which of these two compounds, I and K, are not hydrocarbons? Okay, which of these two compounds, I and K, are not hydrocarbons? Is that correct English here? That the cyproside is not a hydrocarbon. Anyway, so which one is not a hydrocarbon between J and K? Brandon, been quiet. Which one is not a hydrocarbon? So which one, Brandon? You're still thinking it's not a hydrocarbon.
Says J, sir.
Between J and K. Between J and K, you're saying J is not a hydrocarbon. One nine, what do you think? Which one is not a hydrocarbon?
K is not a hydrocarbon there.
Which one? K.
K.
What's
Yes.
the reason?
Because it has an OH at the end, and hydrocarbons are only made of hydrogen and carbon atoms.
You'd almost extend because it has an O, not an O.
Oh,
Because it has an O. What is an hydrocarbon? A hydrocarbon is a compound made of hydrogen and carbon only. But there is oxygen here, so it can be a hydrocarbon. Hydrocarbon means hydrogen and carbon only, Brendan. So K is not a hydrocarbon because it has an oxygen atom. Clear? The table shows some information about 4 alcohols. Methanol, whatever. So these are alcohols in order. I'm sure you can see that it's increasing by CH2. So give the name of this alcohol. So this is methanol, is the first alcohol, followed by what? 2 carbons,
Ethanol.
ethanol. Propanol, 3 carbons, butanol, easy thing. Then they want you to, so you have to check the trends. So to predict, a student predicts that the density of the alcohol increases as the carbon atoms increase. Does the data in the table support this prediction? Explain in your answer, that's correct. They say, what are they saying? The density. So the density, as we go down the group, the density is what? Is increasing. Suggest a value for the boiling point. Yeah, this is a good, so they love these suggestions. So what will be the correct suggestion here? Just check the trend there, what's happening. So suggest a good value there with that boiling point. Try to work it out.
so would it be 60?
Now, what we do is we check by what we'll see. Maybe you're correct. Looks like it's not a bad value. We check what's the increase here. As we're going to do, what's the difference between these two? 17, huh? What is the difference here? What difference we get? 19, huh? So we can tell that roughly it's 17 or 19. If you subtract 19, you get 60, you're not penalized. If you had subtracted 17 there and you get maybe 62, you're not penalized. Make sense? Clear now? because you're trying to follow the trend. Make sense now? Suggestion question there. The alcohol with the formula C2H6O burns in limited oxygen supply. In limited. So if it's in limited, it means incomplete combustion. Clear? Incomplete combustion. Because we don't have enough oxygen. Incomplete combustion. And under incomplete combustion, we always produce carbon monoxide and water. So let's balance together. How many carbons are there? 1, 2. So we need to put 2 here. Clear now? How many hydrogens do we have here? 6. So how many do we need to put here? 3, because 3 times 2 is 6. But the moment we do that, how many oxygens do we have here? We have 2 oxygens plus, how many oxygens here? 3 oxygens, which gives us 5 what? Oxygen atoms. 5 oxygen atoms. Now, if we take 1 oxygen atom from these 5, we are left with 4 oxygen atoms, which means there we need to have 4, which is balanced, because we have 4 there plus 1, 5. Clear? Balanced equation. Make sense? 2 marks. What is the adverse effect of carbon monoxide on health? Should know that from biology. Carbon monoxide. It can combine with hemoglobin. I thought you knew that. And it prevents which is dangerous. It prevents the hemoglobin from combining with what? With oxygen. How do you get that? It's poisonous. That's how it affects the human health. Clear? Dangerous. Petroleum is a mixture of hydrocarbons. What is meant by the term hydrocarbon? We talked about it. What's the definition again? 1 mark, hydrocarbon.
A compound made of hydrogen and carbon only.
A compound made of hydrogen and carbon only. Alkanes and alkenes are the hydrocarbons in your syllabus. See, this question has 5 marks. Petroleum can be separated into different fractions by fractional distillation. The diagram shows a fractional column. The fractions are shown by the letters A, B, C, D, E. Describe how fractional distillation is used to separate petroleum into fractions. Changes. Your answer should include changes of state, difference in boiling point. 5 good marks. So what's the first point? 5 marks. We can try that. Who can try? We've lost someone. Oh, maybe it's Lila. So we can try that.
I'm not sure, but is the petroleum heated?
So the first thing, just to correct your point, is that you see this way there's the furnace here. The petroleum is heated at high temperatures in the furnace here, and it vaporizes altogether. The petroleum is heated at very high temperatures in the furnace, and it vaporizes. Clear? That's the first point. It vaporizes. Is that making sense? Then the smaller fractions, or the lighter fractions that are less heavier, the lighter fractions with low boiling point go to the top. Are we together? The top is cooler and the bottom is water. Are we together? So the top is cooler, the bottom is water. So I'm saying the fractions that are lighter with less boiling points go to the what? To the top. Clear? Then the ones that are heavy with high boiling point go to the what? To the bottom. Clear? Then as they are cooled down, the fractions, they condense. Clear? And they are collected. But they are collected due to different boiling what? Boiling points. I hope it makes sense now.
Sir, please may you repeat the last thing that you said?
I said the first thing, okay, this, I'm sure we understood this part. It's vaporized
Yes.
at high temperatures. When it vaporizes at high temperatures, I said the bottom part of the fractional column is water and the top is cooler. So I said the fractions with that are light with low boiling points, they go to the top. And the ones with the heavy, that are heavy and with high boiling points go to the bottom. Clear? Then I also said the last point that now as the temperature decreases, the fractions condense and they are collected by their different boiling points. Clear? Makes
Thank
sense?
you.
That's how you end the 5 marks. Then. Good question. Huh? The properties of fractions are shown in the table. Properties of fractions are shown in the table. So fraction A, you see, 1 to 4 means number of carbon atoms. Huh? These are gases. Huh? These are liquids. Huh? Okay, and it goes on like that. Anyway, they're telling you the boiling point range. Then describe how the number of carbon atoms affect the boiling range. It's easier. As the number of carbon atoms is increasing, the boiling point is what? Is increasing. Can you see? See 1 to 4 carbons, less than 40 degrees. 4 to 10 carbons, 40 to 160. Can you see that? So as the number of carbon atoms increase, the boiling range increase. Determine the percentage by mass of F. So how do you find it? It's easy. Huh? How do you find this? F, Lila? Percentage is the one that is missing. How do you find it? It's not difficult. Maybe it's to analyze your. What's the total here? 100. So it means if you add that plus that plus that plus that plus that plus what's missing, you should get what? 100. So you simply add 14 plus 3 plus 18 plus 9 plus 9. Subtract from 100. Then you get the percentage by mass of the fraction missing.
I think it's 52.
52.
Okay. Okay, wait a moment. Which one of the fractions is mainly gaseous at 25 degrees? Is mainly gaseous at 25 degrees. So what does boiling point mean? It means remember, gaseous at 25 degrees. Huh? So this boils at what? At 40 degrees. Huh? Boiling, I'm sure you know that it means at less than 40 degrees. Oh, sorry about that. So it means it's air because it turns to a gas at less than 40 degrees. Now, if you look at these ones here, they turn to a gas after 40 degrees, the rest of them. So it means before 40 degrees, they are not gases. Huh? Clear now? So A is the only one that can be gaseous at 25 degrees, which is at room temperature, like what I mentioned. Give one use of bitumen. What do we use that? We know that for road constructions, is the main component for your tar. Fraction C can be cracked to form alkenes. Describe one condition required for cracking. What did you say? High pressure, high temperature, or a
And a
catalyst?
catalyst.
Yes. Now, can you complete that? So tell me that's easy. Complete the chemical reaction for the cracking.
So would it be C5H10?
Yes, we said they should balance. So this is 7, you subtract from this. Then you get C7, like what she's saying. H, you subtract. So you get 10. Is that 10? Or I'm lying? Is that 10 there?
So is it 5?
20.
Oh, sorry. C5 doesn't make any sense. H10, huh? Which is butene. Unsaturated. Clear? Okay, these are your answers and whatever. Anyway, now let's look at last year's June paper, or so to say. Now they are giving you certain things that, yeah, you might get certain things that are not like you haven't read in your book, but it's fine. You apply your knowledge of organic chemistry, like what they've done here. Alkynes and alkenes are homologous series of unsaturated hydrocarbons. All alkynes contain this. So that I'm saying this in your book, you don't find it, but they're telling you that. So a triple bond like this. Then complete table 6.1 showing the information. Okay, complete the table 6 showing the information about the first 3 alkynes. So we know that we are always adding, it's the same, we are always adding a CH2. So if we check here, we have added a CH2. That's why now we have CH like this. Makes sense? Then there you see we are adding a CH2 there. And we now have this. So what will be the suggestive name here? 3 carbons is what? Pro? Pli, I'm sure you know that. So there it will be what? Look at the naming here. So it will be what? Pro? What will be the name? Ethny.
Would it be propi with propi? I don't know how to say it.
Prop. The double whatever is on position 1 here. So you can also say prop 1 in. Clear? The triple bond here. Make sense? Then the formula is not easy. Remember, this is CH2H4. So this is C1234, like this. Clear now? H, you are simply adding a CH2 there, so it's H6 here. But anyway, you can count 4, 6. Clear now? Not difficult, huh? Then you say, it's not in the syllabus. They simply wanted you to apply that, no? Clear? Because this is from a very recent paper. Eh? Compounds in the same homologous series have the same general formula. Compounds in the same compounds in the same homologous series have the same general formula. Give 2 other characteristics. So what are the other?
Similar chemical
Yes,
properties.
similar chemical properties, correct. Properties. Same or show it. Okay, they show a trend. Show correct English. Show a trend in physical properties. Clear? Like you saw the melting boiling point there and the density was increasing. That's a trend that we're talking about as you go down the group or decreasing. What else?
Same functional group.
Same functional group. I'm just listing them because you might get 4. Same functional group. And the last one. So there is 1, 2, 3, 4. It's actually 5. Huh? What's the last one? Consecutive groups differ by what? Lila? Always differ by CH2. Clear? They always differ by CH2 in any homologous series, in any family. Clear? Deduce the general formula. So this is one of the questions, anyway, you might lose there. So let's look at this. What could be the general formula here? They're saying deduce. Let's see here. This is H1, H2, H2. Then H3, okay. The general formula. So what could be the formula here? Then C, H4. What do you think, Mr. Brandon? Deduce the general formula. Tricky one, eh? Let's see. 2, I want to see what's happening to the hydrogen. 2 what? Then 4, 6, huh? So this one is increasing. I want to concentrate on the hydrogen here. I want to use maths, your sequences. Huh? This one is increasing by 2. This one is increasing by 2. Huh? So it's a 2n multiplication table. Is that clear? So here the first one is 2. So if the before 2, it will be 0. So it's simply a 2n on the hydrogen. Are we agree? From 2 sequence. So H2n. Then on the carbons, it's simply Cn. No, it's not correct. Or if I say C3 here, then that will give me, that will be wrong. Okay, because the formula has to. So what's the correct formula then? Cn what? 1, 2, Cn. Deduce the general formula of our what do you think? The guys are quiet now. Okay, let's go back to the table so that you think from the table. CnH what? What if we say CnH2n minus 2? Anyway, if you lose the 1 mark, it won't stop you from getting an A star or an A. Yeah? So let's see if it works. C1 here, sorry, when H is equal to 2, it will be 2 here. Then 2 times 2 is 4 minus 2 is 2 here. Let's work here. When C is equal to 3, it's C3, H. 2 times 3, 6 minus 2, 4, correct? Huh? Can you see that? So it's Hn to n minus 2. Huh? Clear? Alkynes are unsaturated huh? Because they have a double bond. So you can use bromine what? Bromine water. Clear? And they will decolorize, both they've got a triple bond, huh? They will decolorize bromine water. Clear? Why? Because they are unsaturated. Make sense? Ethane and but2-ene are alkenes. Draw the displayed formula for what? So I want you to pay attention to this word here. Clear? Maybe your teacher didn't explain this. Because if we have here something like this, then I'll show you what it means. If I have put one in here, okay, in as in NE. So this 2 means the double bond. Remember, it's but you said it's 4. It means the double bond is on position what? On the second carbon. Clear? If it's 1 like this, it means the double bond is on the first carbon. I hope it's making sense. The double bond here, in, it means the double bond on the second carbon. 1, 2. That's what I mean. So there you have your hydrogens. Remember, it's always Cn, H2n. Huh? You can't have hydrogens there. You can only have that if it's a saturated. Clear? Make sense? The difference there.
Yes, sir.
Draw a dot and cross diagram, dot and cross, to show a molecule of ethane showing outer electrons only. Chemical bonding, covalent. Eh? So if it's double bond, I want you to pay attention to this. If it's double bond, what it simply means is a double like this. I'm sure you know that. That's what it means. Because why? I've got a double bond here. One pair that are sharing. Clear? Okay. So what you do there is you can do a key like this. Then you can say maybe X is coming from what? From carbon. Clear? Then this one is coming from hydrogen. Then remember I've got CH4 here. So there I will have a hydrogen here. Then the hydrogen has got a pair that is a single pair like this. Huh? Then I have another single pair here between hydrogen and, I'm sure you know that. That's what we are meaning there. Then there, so you're allowed to do this. I have because I'm showing the outer electrons, I have also a pair here. Then there I also have a pair like this. Or alternatively, you're allowed to do this. Remember, I've got 2 carbons here. So I'm going to draw the 2 carbons like this. So carbon, carbon here. Then I do my double pairing. I think this is what you are used to. Clear? Then I've got a hydrogen there. Hydrogen can only take 2 electrons. Huh? So this is my outer shell hydrogen here. Then I've got another hydrogen there. Like this. Huh? Then there I will have a hydrogen. Like this. Huh? Covalent bonding topic. Then there I'll have a hydrogen. So 4, 6, 8 balance. Huh? 4, 6, 8 balance. Clear? Hydrogen, hydrogen, hydrogen. Make sense? Or nine?
Yes, sir.
Okay. Now, ethene can be converted into ethanoic acid by a two-stage process. In one stage, ethane is converted into ethanol by a catalytic addition. So you're adding water, which you add steam to form an alcohol. Suggest why this is an addition reaction. What's the reason? Why is it not condensation? Why is it addition? What did you say is the difference? If you are looking at this, Tino, why is it? You've been very quiet. Why is it an addition reaction? Addition reaction, no byproducts. It's simply adding. You don't have any byproducts. That's what it means. Condensation, you take away water or a molecule. Because byproducts, no byproducts. They form one thing. That's addition reaction. A catalyst is used in one stage. State one other condition that is used. So there you use heat, high temperature, because the water has to be steam when you are reacting this. Okay. Now state what must be reacted with ethanol to form what? Ethanoic acid. So you can simply react with the oxygen or with a oxidizing agent. Because if you leave an alcohol open, it will oxidize on itself altogether. Oxidizing agent in a lab is potassium permanganate 7. Potassium permanganate 7 or potassium dichromate. Clear? Potassium permanganate 7, potassium dichromate. Are we together? So this one, I'm sure you know that is pink. I'm sure I've seen it in the lab. And what's the color of this one? Is orange. When it's oxidized, it's reduced itself to a green color here. Clear? This one normally turns from pink to purple or less colorless. Clear now? Because an oxidizing agent is something that is reduced. It oxidizes the ethanol, but itself is what? It's reduced. Clear? What's happening to my paper? Oh, wait a minute. Did we skip something? No. Carboxylic acids can be converted into esters. Propanoic acid and methanol react to form an ester that has got this formula here. Give the name. So I explained the other day. I said the alcohol part, because we're saying propanoic acid. So the first naming comes from the alcohol here. From the alcohol, we get methyl. Clear? So it's methyl propanoate. I'll explain just now. Methyl propanoate. What's the correct spelling? Propanoate. Clear? Methyl propanoate. So let me show you the chemistry of what happens before we just jump to the formula. Okay, just to revise quickly here. Propanoic acid, it means how many carbons here? 3 carbons. Clear? So I have a CH3 like this for the first carbon. Then the second carbon is bonded to 2 hydrogens like this. Then the last carbon is simply bonded to your acid group like this. Clear? The last carbon is always bonded to if it's carboxylic acid plus Methanol means 1 carbon. Remember, I told you the formula is CnH2n plus 1 OH. So if it's 1 carbon here, it's simply C1. HCH3, you see this? This is 1 OH. Make sense? Like this. So it's a 1 like this. OH. Clear now? Now, this is what I want. So this is what they're not asking. They're asking for the actual compound, but I'm just helping you in an exam. You can do that, then you can always wrap or work it on the side. So this is what I want you to get now to master this, is that we remove this part here. Clear? We remove that part. Then this part here, which is the methyl is CH3, yeah, is the one that gets attached here. Clear? So this hydrogen reacts with this. It's a condensation reaction to form water. React with this part here to form water. So water is the byproduct, H2O. The hydroxyl and this hydrogen. Clear? Then this compound, now the ester, now it should be like this. The one that they wanted you to draw. Oh, sorry. So I'm saying hydrogen, CH3. So follow me, CH3 there. This part does not change. It's this part that is affected. So CH here. Then this double bond here remains. But on this part now, I'll have an OCH3. That's what I meant. I'm adding this CH3 on this part. And the naming starts from here. Methylpropanoate. 1, 2, 3. Clear? Make sense?
Yes, sir.
Propanoate. Name another ester with the molecular formula C4. So you see the one that we're dealing with is what? C4H. Okay, so if it's another, it means the same. So it's an isomer because the same what? Same molecular formula. Can you see that? It's an isomer. So what could be an isomer of this? Let's think chemistry here. We have 1, 2, 3 here. Okay, so I messed up. Huh? So we are supposed to have another, because this is CH4. I didn't see that. We're supposed to have another. I'll show you just now. The mistake that I made is on this here. We're saying proper now, and the methanol. Oh, no, that's correct. 4 carbons, yes. So let's work out. So what could be the isomer here? Let's think of the isomer. So let's draw the only structure here, and we think of the isomer for this part here. Well, it's the same formula. So we have 1, 2, 3, double bond, OCH3, hydrogen, hydrogen, hydrogen. So what isomer can we have? We play around with this. Huh? So let's see, CH3, 1, 2, 3. Name another ester with the molecular formula C4H8. Or C4H8. Double bond. Carbon. So what could be another with almost same formula? Can't we have, look at this. Let's see what I'm thinking here. Instead of this here, I'm going to have, remember I have 1, 2, 3. So let me concentrate on the last part. So if I have 1, 2, then I have a double bond here. Let's see the chemistry if it's correct. Then I have an O here. So you're going to see what I'm going to do here. Remember, I'm talking of isomers here. But this is actually a different compound. So if I have CH3 like this, then I have O here. Then instead of having a methyl here, I'm going to have an ethyl, which is CH3, CH2, CH3 here. So let's see, 1, 2, 3, 4. So it's C4, clear? Hydrogens, 3, 5, 6, 7, 8. Can you see that? Same formula. Carbons, 4. Oxygens, 2. Can you see that? That's the correct one here. So this is an ethyl. I'm sure you can see that. Ethyl. Now, 2 carbons here, if it was ethanoic acid. So ethyl, ethanoate. Clear? Ethyl, ethanoate. Oh, tricky one. Polyesters are polymers made from dicarboxylic acids. Name one other organic compound which must be used in the formation of polyesters. What do you use? Dicarboxylic acid, you use a diol. Go and read that on polyesters. You use what is called a diol. It's something like this, with simply an OH here, then an HO, diol, 2-hydroxyl. It's called a diol. That's what we use, clear? And this is a condensation polymerization because water is removed. Condensation, clear? Polymerization. When are you writing chemistry? First exam?
On the
Second?
on the 2nd of
November. Which is not this week, it's the other week, is that correct? Or it's this week?
Next week.
It's next week. So what we'll do is we'll do more a full paper 4, then we do a paper 2 or 2 of them during the week and the weekend. Okay, so we have more time to revise chemistry. Okay. For today, I'll give you an early break. Okay.
Thank you, sir.
During the week.
Thank you,
You're
sir.
welcome.